All right, guys, welcome to another episode of CUDA Education. The purpose of this video is just to quickly talk about the intersection shader and how it is in charge of testing the shape of our object inside of the axis aligned bounding boxes. So we have our axis aligned bounding boxes which surrounds the spheres, but the spheres is actually the shape that we are dealing with by default, right? In the ray tracing intersection application, right? So the intersection shader is the guy that does the test. Sphere intersect, right? This float hit, sphere intersect, this test to see if the rays that are traversing the scene are actually going to hit the sphere. Okay, so the intersection shader is what is responsible for all of that, right? Because we basically calculate the sphere and then we calculate the rays that is traversing, and we're trying to see, and we see the rays that are traversing, and we're trying to see, does the sphere and the ray hit each other? If it does hit each other, then we have to display the sphere, right? Because it hits the sphere and reflects back to our eyes and all that stuff. Okay, so this is what this does. Now, what we want to do is we want to be able to we want to we discussed on the whiteboard edition and also briefly in the previous video. We know that the intersection shader is what does the test and basically dictates the mathematical object inside of the axis aligned bounding box, right? So what we want to do is change the shape of the object inside of our intersection shader. And notice that this is dealing with sphere related stuff, but we're gonna basically change it. In this case, we're gonna put cubes. Okay, so we still have our algorithm, but now we're creating cubes. Okay, so I have to, of course, compile my shader because I updated the shader. It's an external file, so I have to update the intersection shader into a new sphere v file, right? So just give me a second to do that. But we could kind of see that the logic changes now because we're now doing cubes, right? So we have changed the intersection shader to, instead of test for spheres, we're now testing for cubes. Let's see if it runs now. So here we go, guys. Now we have cubes, right? Right? So now, instead of the ray testing a sphere, it's testing a cube. And remember the hit shader is just a painter. So it just paints, I guess, whatever we have here, right? So we could do a torus too. So let us change the shape to a torus instead, okay? And let us see, I have to compile again, so bear with me. So let us see what happens when we change the test from a sphere or a cube into instead a torus, right? We should get a different shape. Now, there are other considerations that we have to deal with, which is why it kind of looks a little weird. It's just, there are other things that we have to consider, but I just want to I just want to communicate the point that if we update the intersection shader, if we update the test of what shape we are dealing with, that we effectively will see a different behavior. So we get this guy, right? And it's like kind of, you make your own assessment for what all of this is. But basically, if we like go to the center, we could kind of see a fully formed torus, right? But remember, this torus is created inside of a box that is assuming a sphere, and you know, it's a different cup of tea, right? But I at this point, it's above my pay grade to really figure out why this is happening. But you have the camera considerations, you have the axis aligned bounding box considerations. You'd really have to update the algorithm, you know, fully go through the whole application to accommodate a torus, right? So as a last example, I'm going to do, well, I'll do two more examples. I'll do a cone. I'll do a cone as one example. So let's do a cone. I have to compile. So we're gonna do a cone. So again, intersection shader, test to see if a ray hits, in this case, our cone. And if it hits our cone, you know, notice the math changes, right? Which is expected because we're now calculating for a cone. And if it hits, then the hit shader does the painting, right? But again, so all right, I think I'm good now. So now we get this cone. Again, there are more considerations, but we could kind of see that there's a cone being generated. I guess if we go to the center, we'll see that there's a cone. But you know, you know, it gets tricky, guys. There are more things. You have to update, you know, the source file, the C++ file, all that stuff, right? So we have our cone. And then for the last one, we'll do an ellipsoid, okay? So we're gonna update the algorithm to an ellipsoid, okay? I have to compile the shader. And that's pretty much it. So guys, if you are interested in this stuff, tutorial number 1 is installing the Vulkan API on a Windows-based machine. Tutorial number 15 is installing the all of these examples. Your GPU has to be Vulkan capable. If you want to run the ray tracing stuff, you need to make sure you also are ray tracing capable GPU. So for NVIDIA, it's RTX and above. I don't know about the other vendors. So if we now run our thing, we get an ellipsoid, which I just, you know, it's whatever you want to make of it. You know, like there's camera considerations and culling and all that stuff, right? Above my pay grade at this point, but you get the point, right? So the intersection shader is responsible for testing, for creating the shape and testing whether the ray hits the shape. The hit shader in this example is just the painter, right? So we could visually see what's going on. So I think I'm fully done with this ray tracing intersection stuff for now. I think I'm fully done. I don't know. I mean, obviously, I will circle back if I get some more insight or I find out anything. So this procedural geometry stuff is the ray tracing 10.0 series. So 10.0, 10.1, 10.2, 10.3. I just got to make sure that I get back my spheres. Okay, so I reverted back to spheres and I get back my beautiful spheres. Okay, so yeah, guys, you know, support the channel. You know the deal. Get your friends. If you know anyone that's around you that's artistically inclined, I strongly suggest that you work on you know, getting them involved in this stuff. It's time well spent. You want to be able to put pixels on a screen. Computer graphics is the future. Everything and everyone is going digital. So It's a good skill to have. Thank you for watching. Have a great day.